Let's continue exploring Apache now. We've breezed over this directory block that you see here commented out. This block pertains to the user directory feature, which allows users to publish content from their home directories. It's commented because although the user directory module may be loaded, it's disabled, and as a result, there is no need to have this directory block loaded into the server's memory. But if you do decide to support user directories, then uncomment this entire block, as it will apply the rules that you see here to the user's home directory. Allow override for these directives: authconfig, limit, and file info. In the case of authconfig, if a user determines that from their home directory they'd like to place authentication requirements on content, then you'll allow the user to do so using anything auth related. Options that are to be supported in users' home directories include multiple views, indexes, symlinks if it matches the owner, so the links need to match content owned by the owner of the directory. No execution, with some limits that are set on these types of methods, get and post, etc. Now let's keep scrolling through this document. Directory index is another key directive. Here are files that Apache will serve by default without you having to indicate the file name explicitly. For those of you familiar with IIS, Microsoft's IIS, this is equivalent to the document default, or the default document that you configure. So again, if Apache finds index.html or index.html.var, which is a way to determine based on variables such as language, environmental variables such as language, which default document to serve, then it will serve the page without you requesting the page, equivalent to accessing content without indicating the file name. So IP address, hit the web server, no file name. Below we see another directive, access file name. Whenever you see allow override, none, or anything that has to do with override, it's making reference to this file, the hidden htaccess file. Historically, Apache has supported this file as a means for users to place restrictions or directives on content, so to assign directives to content. In particular, in an ISP setting where you share server space with other people, you may not be granted access to the primary httpd.conf file, but you will be in all likelihood provided access to create your own htaccess file with directives that pertain to your website as opposed to someone else's website. This is the name of the file, the default name of the file that you can create with directives. But in the event that an allow override is set to none for a given directory and its subdirectories, then the hidden htaccess file will have no effect. Here's another directive. It's a files directive which pertains to file types. This tells us that the following lines prevent htaccess and htpassword files from being viewed by web clients. In other words, under no circumstances should Apache serve anything, any file with a .ht suffix, or beginning with a .ht, that is, .ht prefix. So at no point should Apache serve .htaccess or .htpassword or .ht anything. Here we see order, allow, deny, but the one rule that overrides everything is deny from all. So if you attempt to access content such as .htaccess, it will not work. And that's something that we can put as a note to test. Test access to .ht star files from webroot or from anywhere that Apache will serve content. But this is the rule that provides the feature to restrict that type of content. So we've seen directives for directory as well as files. You can control access to files and directories. With files, you're generally indicating a file mask, and with directories, you explicitly, or with a directory directive, you explicitly indicate the directory, although wildcards are supported. To find out types of files, Apache can consult the mime.types file, which has multiple types defined, and that's less etc mime .types, you'll find the various types, PDF, AVI, shockwave, you name it, it's all in here with suffixes associated with them, and Apache can make use of this file to determine what type to send a user. However, outside of mime.types, the default type for HTML content, which includes dynamically created content from files like PHP, ASP, Python, Perl, etc., is text plain or plain text. If the MIME magic module is loaded, then the file conf magic is loaded. Conf is relative to etc httpd, which is indicated by the server root directive, and the magic file we showed you is in that directory. So if indeed mod MIME magic is loaded, this file will be used to help determine file types and serve the appropriate MIME type to the client. Hostname lookups, this is a bad idea. It causes Apache to look up on a per connected host basis the hostname of the connecting user. It wastes resources and can render your web server as slow as molasses. Send file and mmap, those are turned off. They're usually not required. Error log. Again, we mentioned that the symlink logs, which is referenced via the server root, which is in etc httpd, gets created when you start the server. A file named error_log will be the default error log file. And it is the file for the default server as well as for any virtual host that doesn't have an error log defined. So E will just indicate default error log file for all hosts, which means for the default server as well as for virtual hosts. Unless, of course, you override it by indicating the name of an error log file. Apache supports the levels supported by syslog, debug through emergency, those 8 levels, or 0 through 7. The default level is 1. However, you can reduce the verbosity to notice info or lower if you'd like to see more information. This information gets logged to the error log file, not to the general access log file. Let's keep on going. We're moving on to the log format. Apache uses variables or constructs its logging based on variables. The variables all have meaning, such as the host, the connection, so on and so forth, and Apache has a directive which can aggregate those variables and assign them to a name which can be referenced in the main server config or by any virtual host, since virtual host files are included in the main configuration. So here we see a log format with many variables, and it's referenced or named combined. So whenever you make a reference to combine with respect to logging, you're going to get the results of all of these variables. Common has most of the variables found in combined, minus the refer, so in other words, who sent me here, as well as the user agent, in other words, the type of the browser connecting to the server. There are types for refer and agent. If you want to log connecting clients based on refer or user agent alone for the sake of parsing that information and generating reports, then you can cross-reference refer or agent and or agent. Or you can get all the information and post-process using a separate utility. Also, logging in Apache can happen simultaneously, so you can have a virtual host or the main server log using combined to one file as well as using, let's say, refer or agent. You generally wouldn't log using combined and common because combined includes everything included in common plus refer and user agent. But you may want to log combined or common coupled with maybe refer and agent just to split the data out. The general recommendation is that you log using combined and then post-process the information using a tool such as Webalizer. In other words, leave Apache's resources to serving clients as opposed to writing I/O to disk, and it'll be much more effective as a result. And when we fire the server up, we'll see that each of these items, when we allocate, let's say, combined, for example, such as the connecting host, the time, the number of bytes transferred, the size, the refer, are lined up in the log file exactly how they're presented here in the log format area. Here we see another format which uses the mod log IO to present to us combined IO, which, as it tells us, accounts for actual bytes received and sent using uppercase I and O for input-output. It's disabled, but can be turned on if you need that sort of view. And here we see a reference to custom log common, which is commented out. But below we see one that isn't, custom log with combine turned on, which means the refer and user agent variables are made available. So this access log file is the default log file for the default server. Let's just note that. Default log file for default server, and optionally all hosts if you don't indicate a log file, which means other virtual hosts. The server signature feature is turned on, which will include the server version, especially on index-driven pages that look like FTP, or on pages that return errors. An alias is defined whenever the IP address or name of the server is referenced /icons. Apache really calls var www icons. So this is a way of mapping web space to a different file system space, a space that's outside of the document root, similar to a virtual directory in Microsoft IIS. And for each reference directory, especially those that are outside of the document root that are covered by other directory directives, we should have a directory directive. So for var www icons, here are the rules. Indexing in multiple views are permitted. No htaccess or any sort of override file can be used, and everyone can interact with content served from var www icons, which is another thing for us to test. Here's a block from moddav. Apache supports webdav, and if it's enabled, then that feature set is there. Script alias. Apache can serve CGIs or Common Gateway Interface scripts such as Perl, Python, and so on. It does so by default for the default server via /CGI-bin, which is really an alias to var www CGI-bin. So for every non-document root or directory not covered by a directory block, we need a directory block. We should note that. Every directory outside of the document root should have at least one directory directive defined. Otherwise, Apache is likely to throw an error in attempting to serve the content, and it's not that it's not able to read the content. The primary Apache process runs as root, so it can certainly read the content, but whether or not it's permitted to serve the content is based on the rules it finds in its directory directives. So for var www CGI-bin, no overrides are permitted, options none, but everyone can contact the content in this directory. And if we keep on going, we'll see additional settings. We're only at 59%. Icon support, we'll just scroll through very quickly because we'd like to get to the stage where we can start the server. Language support for multiple world languages. Priority beginning with English, followed by many other languages. Default character set, UTF-8, which covers many of the world's languages. Additional application types for compressed items, gzip, tgz, etc. Apache can handle those files easily. And here's some error documents, references for error documents, which Apache ships with a set of. /error points to var www error, which means there's a directory block. And if certain errors are experienced, then Apache has documents, although these are commented out, it has documents to throw or to present us with information. Browser matches, some commented out location directives, which is a way of referencing or rerouting web root requests. And then there's a virtual hosts section where you can populate your virtual hosts using the supported technologies with sample virtual hosts or a sample virtual host container defined, which we'll be looking at momentarily. So let's exit out this document as we have, and what we'd like to now do is start the server and begin exploration. So with that said, our next task is to fire up Apache. So start Apache and continue to explore. To do so, we'll execute service, and no need to memorize, although by now we should know what it is, but in etc initd, we'll find our HTTPD instance. So service HTTPD start. We'll start the server and echo the exit status, and we lost it, but would have told us that it was successful. PSEF grep HTTPD returns the instances, and let's just copy and paste this and dump it into our notes, minus the last item, which really belongs to the grep instance that we ran. So we started it, and this is what was returned. What does this all mean? Well, if you recall from the main Apache configuration file, we saw that Apache starts with the following 8 instances, with the primary instance starting as root, and all of the other instances referencing the PID, the parent PID root, the one started as root. This parent process has access to the entire file system. However, the subsequent processes which users actually connect to run as the user Apache, and these processes can only access content that the user Apache can see. So note, parent Apache process runs as root and can see the entire file system. However, children processes run as Apache and can only see files or directories or directories that Apache :Apache, meaning user group, can see. So keep that in mind whenever you create new document roots for new servers or new hosts, that the server is limited in that capacity, not the root instance, but the instance users communicate with, these 8 instances. So it's up and running as HTTPD. We can confirm also using netstat ntlp grep 80, as Apache is bound to port 80. It's listening to both IP version 4 and IPv6. We know because in the netstat table we see :80, or double colons to indicate all zeros in IPv6, all zeros for all 128 bits, followed by a colon and the port number. And here's the parent process ID of 31324. So Apache's up. When it gets a request in on port 80, it proxies or fields or routes the requests directly to one of the free children. And then that free child services the requests. Now let's try to access content. Now that the server is up and running, we said we wanted to start it and continue exploration. So we'll navigate to the shell and hit on 192.168.199. Now here's the default test page. We did mention that because of the welcome.conf file, if there is no default document such as index.html or index.html.var, which contains logic handling variables that are accessible to Apache, such as environmental variables, then this no index error page is served. And again, we can corroborate that by examining the contents of the confd directory, lsltr, and then cat in the contents of welcome.conf. So again, location match using the regex match. If there is no index.html, serve this particular document from error as no index.html. And if you recall, if we grep error from the conf directory httpd.conf and we pipe it, we'll see the alias. It's in fact on our page. This tells us that the alias error really points to var www error, which means in var www non-HTML error, we will find the various error documents that pertain to the different types of errors, 404s, 403s, 300, 400, 500 errors, and no index.html. This is the document that we were served. We can list the contents of it, and you'll see test page for the Apache HTTP server. This is in the title. Scroll down, test page for the Apache HTTP server. So this page is served var www error no index.html when there is no index.html. Well, that leads us to the next point. Let's create an index.html file. We'll navigate to var www.html where no files currently exist. We'll nano index.html. And the suffix is incorrect, but we'll rename it when we're finished. So HTML, body, and close body. And in it, we'll just center and indicate test of 192.168.75.199 default Apache server. Let's save the changes. We'll move index.thtml to index.html. That was a typo. Now we've got a file, but beware, again, the document must be readable by either the user Apache or the group Apache. In this case, Apache will be able to serve a document, and that is will be able to, because for the other block, or for the last 3 bits in the permission set, everyone can at least read the document, and that's all that's required in order for Apache to serve content from the file. So from the browser, let's attempt to refresh this page, and now notice it returns test of, or the HTML document that we just created. Because again, that simple check in welcome.conf, which is included in the overall configuration, is meant to determine whether or not a directory indexed file, either index.html or index.html.var, exists. If it doesn't, then the error document that's to be thrown is this noindex.html file. So now we can begin serving content from that directory quite easily. Which leads us to another feature of Apache, and that is the ability to support aliases. So fourth task, create an alias for content outside of the web root. And we know the web root to be var www.html, which means we can create content, let's say in var www test alias 1, and in there we'll just populate an index.html file. And we'll copy the one we just created. So we'll copy HTML index.html. First we'll make a directory calling it test alias 1. Then, if successful, we'll copy index.html to test alias 1. And if that's successful, we'll LSL test alias 1. Then that's been successful. Let's modify test alias 1, index.html, and we'll just indicate that this is test alias 1 so that we know it's the file that we created. Now with that said, we need an alias, because if you attempt from the browser to access test alias 1, it'll fail. Because test alias 1 is, or this reference attempts to access test alias 1 beneath the defined document root of var www HTML, which causes Apache to return its signature and an error. This is a 404 error, file not found. So with that said, let's modify that config file, etc httpd.conf. In fact, we can do it from a separate window. We'll nano httpd.conf, and we'll navigate towards the bottom, just to give us some breathing room. We will define an alias using the alias directive for test alias 1, followed by its full path, which is var www test alias 1, and then we'll include a directory directive which includes the full path. We'll close it out. Again, no need to memorize. You can find a directory directive that's included somewhere else in your document and just copy and paste the options that are there. And the more you do so, making use of the existing template, the easier it'll become. You'll get accustomed to the directives. Let's find one for, here is one for the error, and we'll include some of these options here. Allow from all. This should be fine. Then we'll Control V to the bottom and simply paste it. So allow override none, that's always a good option. Options, we can include none, which means you need to have a default page. Add output filter, add handler are not important. We'll allow access from all. So we will not allow someone to place a hidden htaccess file in test alias 1, overriding our directives. There are no options. We won't index it at this point, or follow symlinks, or allow scripts to be executed, or any other feature, multi-views, etc. But we will allow access from all. You need a directory directive to govern the directory that you're serving if it's outside of the web root, unless the directory is a subdirectory of a top-level directory that is already covered by a directory directive in one of the configuration files. Keep that in mind at all times. So we'll save changes. Then we'll restart Apache using service httpd restart. This will restart the config, and let's try not to lose the echo of the exit status. The exit status, by the way, if we haven't mentioned, this $ question variable, it's really a question variable, is updated for every command executed in each unique TTY or terminal. So when you execute echo and you miss the O like I tend to do, you lose the status of the exit status for the last or previously executed command. So here we see it's 127 instead of 0. Had we executed echo $ without messing up the command, it turns 0. So this variable gets updated dynamically, just like PWD and OPWD do as you move about the directory structure. So Apache has been restarted, and we should also make one other observation, and that is, in var log httpd, the logging is taking place. Error and access log files are being written. If you tail var log httpd error log, you'll see anything related to errors as well as the fact that the server has been restarted. And here we see it's configured, it's resuming normal operations. The access log contains attempts to access the server, including the variables that we saw defined in the main configuration file. Connecting hosts, any ident information, which is usually blank, the timestamp of the connection with the GMT offset, the request that was made, get for test alias, which failed, it generated an error of 404, 288 bytes were transferred. Here's the user agent, there was no refer. So the log information is working as expected now from the browser. We should attempt to access test alias 1 again, and there it is, test alias 1. So now we're accessing content that's outside of the web root via this alias. So creating aliases is as simple as we've just shown you. You simply modify the config file, and we'll cat the contents once more, to include an alias named with the alias, or named after the alias that works for you, that's ideal for your situation. It can be any name you'd like, but try not to duplicate them throughout your config. And point it to a hard location on the file system. It doesn't have to be beneath var www. It can be anywhere. But then you need to ensure that there is a directory directive which governs access to the physical location with appropriate directives. Allow override none is optional, but you do need to indicate whether or not access is allowed to the content. The primary Apache process, or the parent process, always has access. However, Apache honors the directives that it finds throughout its config files, and whether or not it can see the content is independent of whether or not it will serve you the content. Now, before we move on too far and forget, let's set as another task that will set Apache up to restart appropriately. So we've set up our alias using alias test alias 1, and we followed this up with a directory directive block pointing to the physical location of the directory. And again, many of the Apache directives follow this sort of format, but you can always consult the documentation to get a clear understanding of how the directives work. Once you work with a few of them, you should have very little trouble working with most of them. So we set allow override to none, and we also set order, allow deny, and allow from all to allow access to the content. Now let's just ensure that Apache will start when the system boots. And this you should know how to do using check config level 3.5 for run levels 3 and 5 HTTPD on, followed by check config list HTTPD will confirm for us that Apache will become a part of our normal modus operandi, and we'll try that. Now we see it's set for 3 and 5, so it will be on when the system boots, barring no catastrophic errors when the system is turned on. Now next we're going to look at virtual hosts, a way to map user requests to different IP addresses as well as to the same IP address, but to route that traffic into different directories, different areas of content on our server.